Okay, hello guys. Today our topic is about compound interest. Okay, so we are talking about how the interest in different ways when you're saving or depositing in the bank. Okay, so let's move into the first part about the concept of the compound interest. Okay, so what is compound mean right here in the interest part? So here is just a definition of this. And compound interest is interest interest. Okay, so maybe this word I think is a little bit confusing for you. Okay, so let's just look into the sentence. After year one, the interest is added to the principal. Okay. So for example, like if you have $100, you deposit it into the bank, and maybe the rate is for 1%. Okay. So after 1 year, you are earning about $100 times 1% is $1, right? So now your total amount is 101, right? Okay, that's your total amount in the bank. So maybe your bank manager will tell you that, oh, so we have a compound interest deposit, so you can just save in $101 into the bank at this year. Okay. So that means you also earn 1% rate in the bank account and you are gained 101. You find here is for the base money plus like earning you have. So it's 100 plus 1 is 101, then times 1%. So you are earn about $1.01 at the next year. So you are earn about like $102.1. So you're fine for this kind of compound interest, always following a rules that you're just using the new interest to become, using the interest to grow interest, right? Okay. So sometimes you heard some people will say that if you're a rich man, if you get money, you're just using the money to burn some other kind of money. Okay. Money is a matter of the other monies. Okay. Very interesting. So we call this results as the exponential growth, and this is called compound interest. Okay. So it's not very difficult. Right here, we give you a formula about this. That is A, like the total amount equals to P times 1 plus R over 100. And here is power is n. Okay. So what does it mean? Okay. So if you just gained 1% in the bank, you will put your initial money right here. It's $100, right? So for the first year, your total amount will be 100 times 1 is the base amount, right? And then plus the ratio R. And here the ratio R, like R% means the ratio, okay? So this is the money you earn. So 100 times 1 plus R% means the total amount you gain after 1 year, okay? So when you come to your second year, you are using the total amount times 1 plus R ratio over 100, right? You times 1 plus R% again, right? And the third year, you're just using the total amount to times 1 and also gives you a new interest, right? That is this. So after n years, you'll find that you're gained about 100 times 1 plus R over 100 and the power is n, right? That is for the formula right here, okay? So you know that the A is total amount, P is a principal or start amount, and R is a ratio, and N means a number of years, okay? So here is an example like here. It's that invest $4,000 at 5% compound interest for 3 years, right? So we knew that here for the base money is 4,000, right? And the compound interest is for 5%, right? So after 1 year, you will gained a lot of money, and the total amount is 1 plus 5%, right? 4,000 times 1 means the original or the base amount, right? And 4,000 times 5% means the money you earned. So here is for 4,000 times, like here is for 1.05, okay? And this is for the first year. And then the second year, you are gain 4,000 times 1.05, and then you're using the money, original money added with your interest, right? And then times 1 plus 5%, right? This is the second year, your base money. Your base money is just after 1 year, you gain 4,000 times 1.05, right? And this is the interest. So you'll find after 2 years, it's 4,000 times 1.05 squared, okay? And at the third year, your find is 4,000 times 1.05 squared, and then also times 1 plus 5%, right? So you will gain 4,000 times 1.05 cube. Okay, that is for the total amount right here. Okay, so the problem is that like how much money you earned after this, you can say, oh, 4,000 times 1.05 cube minus 4,000, you'll find the interest you earned, that is for $630.5. Okay. really a great amount. Okay, just 3 years, just make your like the money in your bank just gain a lot of like I guess here 600 over 4,000, maybe it's for like 5%, 5% or more. Okay, this is a great amount. Okay. So for here, let's go into the exponential decay. Okay, we have the raise and we must have a decay. Okay, so like some population, you will know that in East Asia, like Japan, like China, like South Korea, you'll find a lot of countries are facing a problem that the population is decaying. Okay, so why is the population decaying? Because burdens for everyday daily life is very big. So we rather to not get married and not to get a baby. So that like population is decreasing. Okay. So like using this, you can just also using like the compound interest model like here, the P plus times 1 plus R ratio ends, right? And here you can also use this formula like P times 1 minus R ratio ends, okay? So here we can set, there's an example, like a car costs $20,000 and here it decreases by 5% per year. Okay, so what's the value after 4 years? So we knew that for each year you're just using 20,000 times 1 minus 15%, right? This is original money, and then you times 15%, that means you lost the money, right? Where the value you decreasing. And then after 4 years and at the second year, you also has to times 85%, right? 1 minus 25, 15%. And then the third year, you also has to times 1 minus 15%. So for 4 years, you have to times 4 times of 1 minus 15%, right? So the value here is for 20,000 times 0.85 force, and the total value here is for 10,000. Okay, that is for like these problems. I guess is very interesting. So you can find maybe after 4 years, your value of a car just decreasing and to become a half of the original price. So I guess you have to sell your car as quick as possible, right? Okay. And here's some compound interval. Like here, let's set $1,000 at 10% per annum and compound semi-annually for a year, right? So we knew that for per annum is 10%. So for per period is 10% over two, right? Because it's semi-annual, right? So it's 5%. So we knew that here, like we have two periods because it's for a year. So you can calculate that 1,000 times 1.05 squared equals to 1,100.5. Like these problems, you just change your time. Sometimes your time is not very exactly on that day, so you have to maybe find the value, like find the number of the days, and to find what is the relationship between each other. Okay. So here are some practice for you, okay? I hope you can just do it for these problems by yourself. And if you want to do them yourself, you can just pause the video. And if not, you can just keep on going and listen for these problems together, okay? So the first problem is that calculate the final value for $5,000 invested at 4% compound interest for 5 years, right? So for every year you get your gain for 4%, right? So like the first year you gain 5,000 times 4% and added with the original value in your account. So you are gain like 5,000 times 1 plus 4% for a total amount, right? And at the second year, you are getting like also using this to times 1 plus 4%, right? So after 5 years, you're finally getting about 5,000 times 1 plus 4% fifth, right? This is for a total amount. And then you can use the calculator to calculate this value, okay? This is our first problem. And second problem is that a population of 20,000 bacteria increased by 12% every hour. How many are there after 6 hours? Okay. So for like these problems, you can set like 20,000, we have to times 1 plus 12%, right? This is for the first hour. And for 6 hour, you have to 6 to become the power. Okay. So right now, this 1 plus 12% 6 means there are 6 1 plus 12% brackets times together. Okay. That make a product. Okay. And for the third problem, the machine costs 15,000 and it like decreasing the rate for 20%, right? Calculate this value after 3 years, right? So it's also very interesting because using the same formula, but now you have to change the plus into the minus, right? So it's 15,000 times 1 minus 20% because it's for each year is rate or each like value for decreasing, okay? And then you have to cube like here, 1 minus 20% cube, okay? That's for this. So you are getting the final value of here, okay? 15,000 times 1 minus 20% cube. And then the last problem is that Bank A offers 5% simple interest and Bank B offers 4.5% compound interest. And which is better for 3 years investment? You know that here, for simple interest, you will know that is only for like you have a original amount. Maybe you can just consider you have $100. Okay. So after for 3 years, you will know that it's 5% times 3, right? That is the money you gained. So here is for 5 times 3 is 15, right? And for 4.5 compound interest, you will know that here is for 100 times 4.5%, right? Okay. But to know that it has to become for 3 years. So like this is just for first year, you get the first year's total amount and then you make a cube on the power. So you get a total amount after 3 years, right? To minus a thousand, sorry, to minus 100, you will get what money you get. Okay, so you can make a comparison right here. So you'll find that maybe for the bank B, it will get a higher rate. Okay, so that's for today's our total lesson. I hope you can get understanding for how to compare with compound interest and to know what is the difference between simple interest and this. Okay, they are very important for you in IGCSE papers. Okay, so that's all for today's lesson. See you next day. Bye.